All right. So a couple of things that were brought to my attention since I did this last week. One of the things that to pay attention to is sometimes you'll see in the problem, it'll say to give, a certain quantity of a medication, and then it'll say BID. And then the question will ask, how many capsules do you give either per dose, or sometimes it'll ask how many capsules to give per day. So if it's per dose, you ignore the BID because you just need to know how much you need to give in that dose. And if it says per day, then you need to know that you got to give that twice in a day, okay? Most of the time your questions are going to ask you, and it's going to be assumed, especially if it doesn't tell you specifically, it's going to be in per dose. But just pay attention because sometimes your instructors like to ask you that per day type question. And I just want to make sure you don't goof that one up if you see that. So that was the first thing I wanted to address before I move forward. So let's talk about fluid replacement. Now, most of these problems, you can do things, what's called the order over have kind of equation, especially if you are, let's just say you are, averse to using dimensional analysis, which is perfectly fine as long as you're getting the right answers. Whatever technique you use will work out great. So in your in the review packet, like the intro stuff, I give you a formula to figure out these fluid replacement problems. Now, this fluid replacement problem is very specific to Allegheny campus. Other colleges or even other branches for CCAC's nursing program, they will address this question a little bit differently, meaning you need to know the difference between solids and liquids and how that might contribute to fluid replacement volume. This is just how much do we need to give somebody once they've voided a certain amount. So for question 13, it says for every 120 milliliters of urine output, you're supposed to replace that with 30 milliliters of water. If urine output for the last 3 hours is 200 milliliters, then how much should you replace with? So the formula I came up with is going to look like this. You take your actual, so I'm just going to write actual milliliters out over the, I guess the given milliliters out. You could also call it theoretical, but I think some of you might get upset if I write theoretical. The given milliliters out. So in this particular equation, the actual milliliters out was 200 milliliters, and then the given milliliters out is the 120 milliliters. And I hope that you see that. Then you're just going to multiply that by whatever the replacement volume is. And that's how you would solve all of these fluid replacement problems. So let's take number 13 for an example. The actual milliliters out is 200 milliliters. The given milliliters out was 120. And then the replacement is 30 milliliters. And I can tell you that if you set that up that way every single time, you will get the answer that you're looking for. So for this particular question, you would just do 200 times 30 divided by 120, and you'll get 50 milliliters.
I'm sorry, I just joined. Where are you getting those questions from? Is it
from the practice test.
Practice test. Is it what you told us to go and download from the NUR 110 120 orientation?
Maybe. I don't know what they've given you. I gave this link to some people, or if you were on last week, I posted it up in the chat. And then I also gave the link to download this to Professor Walters, and then I also gave it to a few people who emailed me about it. So if you don't have the practice test, it's called the 17 Spring NSG 110 practice test. Just message me You can email me and I'll write my email up here. Hold on, and I'll put that up. And I'll correct the formatting here. I'm sorry.
That's okay. Thank you.
You're welcome. Sorry.
So basically, the actual over given times replacement is what? What are we solving for?
This is this is what we're looking for, is how much fluid to give the patient.
Okay.
You're welcome. Yeah, so
Thank
that's
you.
my email address. If you do not have a copy of the practice test, if you email me, I will give you the link. If you already to my OneDrive, the college gives all of us, including you guys, access to Microsoft OneDrive. And so if you don't have this, and if you do have it, go ahead and share it with whomever, however you guys disseminate information amongst your class. That is not a private link. That's for anybody and everybody.
All right. Thank you.
You're welcome. All right. All right. So let's look at the same question just like that. Now you can try this on your own. So somebody tell me for number 19 if you have this. And if you don't have this, just listen. The question says, for every 115 milliliters of urine output, you're going to replace with 40 milliliters of water via PEG tube, which is just the way it's being administered, every 4 hours. If urine output for the last 4 hours is 325 milliliters, then the fluid replacement volume would be what number? So for those of you who have that question in front of you, where would I start?
Would start with the actual milliliters out. So that would be 325.
You got it. So this is number, oops. So again, this is number 19. So we start with the actual out, which was 325 milliliters. Good.
Then you would do that over 115.
115, which is the given milliliters out or theoretical.
Multiply that by or replace it with 40.
Got
so
it.
Do times 40. And then you will multiply 325 milliliters times 40 milliliters. And then you will divide that by 115. Now I got 113.
Good. That's what I got as well. At least that's what I wrote in the key. So again, you just take the actual out over the expected out or the given out. You can even say the theoretical out if you want to rehash chemistry nightmares, times the replacement volume. It'll work that way every single time. Okay. One of the tricks here is that the every 4 hours, it really doesn't matter the time. It just matters what you're replacing with and with how much. So even if you check that after 8 hours, that wouldn't affect anything. It would still be the same equation here. So actual out over the given out times the replacement, and it'll work that way every single time for fluid replacement type questions. All right. The next thing was about the reconstitution question. So that was 17 and 18. So what I'm going to do is I'll show you, it doesn't matter which one I show you first, but let's just go ahead and do 17. So we'll do it in order. And what I do for 17 will also apply to 18. They're basically the same question. It's just a different medication and a different label. Now, what I mean by label, like for 17, it says the order is Unison 1750 milligrams IM Q6H. Using the information from the package insert below, determine how many milliliters of this antibiotic you would administer from the 3-gram vial. So it tells you which vial to utilize. Now, the picture shows it has three columns. The first column says unison vial size, 1.5 grams, and then 3 grams. Then it says volume of diluent to be added, 3.2 milliliters, 6.4 milliliters, and then withdrawal volume, 4 milliliters and 8 milliliters. And so the question is, we want to calculate the amount of milligrams in the unison vial size. Now, here's the thing. Anytime, at least for dosage calc math, anytime you see something that says volume of diluent added, when you see that, you just need to know to ignore that column. And here's why. In the pharmacy, the pharmacist is going to receive a medication. Let's just say this is my medication, and it's going to be in a powdered form. There's going to be a fill line, and what the pharmacy and even some other places, what they're going to do is they're going to come in and they're going to add water to the fill line, and that water is going to be in the form of deionized water. Okay, then they're going to shake it up, and when they're done shaking it up, we will have our reconstituted solution. So it'll just basically be the whole thing here. We'll just say it's some sort of green solution once you mix it all up. Okay, so when we get to this point, the volume added just tells us how much water to add. So in the 1.5 gram tube, I would add 3.2 milliliters. In the 3 gram tube, I would add 6.4 milliliters. Since we're talking about the 3 gram tube, this is still the 3 gram tube here, and this is the 3 gram tube here. Both the total volume, that's what's indicated with this line here, is indicating the total volume. So the total volume for the 3 gram vial is 8 milliliters. If we were looking at the 1.5 gram tube, it would be exactly half. We would say it's the 4 milliliter. Okay, that's the difference. Again, we just add 6.4 milliliters to get up to 8 milliliters, or we would add 3.2 milliliters to get up to 4 milliliters for our given gram thing. So what I've written here is what's important. The volume of diluent added is only important for the actual mixing of the medication. Okay, and that's not something that you are doing math-wise. It might be something you do, but most of the time, especially if you're in a hospital setting, you're going to get it as a suspension and that's the same thing. What a reconstitution is, just the same words, just talk about something different. But it's the same thing as far as what you're getting, or you'd be receiving that from the pharmacy. Just like if you've ever had, or if you have kids, or if you remember when you were a kid and taking the pink amoxicillin solution, where the pharmacy gave it to your mom, or you gave it to your kids, they tell you to shake it up really well, and then to administer. When the pharmacy has it, it's a powder. They added the water and then give it to the patient, and then the patient brings it home, keeps it in their fridge, gives it to their kid. So that's what this is. The milliliters of diluent added is not something you need to know in order to solve this equation. Now that you know that, there's a couple things you need to, or there's one other thing you need to do in order to solve this equation. So we have milligrams, grams, and milliliters listed there, and we're going to ignore the volume of diluent to be added because I already explained why. So you don't need to worry about 3.2 or 6.4. That has no variant on this equation. All I care about is the total volume and the vial size. So my order is 1750 milligrams, because that's my order. And what do I have strength-wise? Well, I have 3 grams. 3 grams is the same as 3,000 milligrams, right? And again, you know that because you've been practicing. You know that 1 gram is 1,000 milligrams. So 3 grams would be 3,000 milligrams times your replacement volume, your replacement volume, but times your quantity, which is the 8 milliliters. Go ahead.
I was just asking that 3 grams is what? You said the 1750 milligrams is order.
Correct.
So
And
I'm
3 grams
asking
is what you have stock.
what you have stock.
Yep. It's for the medication Unison. So the order for Unison is 1750 milligrams, and then what you have available is 3 grams.
And then the 8 milliliter is the volume or what?
Is the total volume, yes.
Okay, thanks.
You're welcome. This will make much more sense when you have the test in front of you to look at, and I realize not everyone has it yet. But I do want you to know that it should be on your Blackboard site. If not, if it hadn't been given to you via a packet at the beginning of the semester. All right. So 1750 times 8 divided by 3,000. And then you'll actually get 4.666666. Anyone want to take a guess of what the correct answer is?
4.7, you'll round it.
You round it to the nearest tenth. You got it. You don't have to write what I'm writing here, but rounded to the 10th. Okay? I just want you to know why I did that. So when you get your answer and it says 4.666666 repeating, you know to round that to the nearest 10th. Okay? You should also know that if you were to get an answer that said 4.9999999, that's 5. Okay? You don't leave that at 4.9. You'd make that 5 because most likely that was just a calculator. If you don't multiply across the top and then divide by the bottom, it can sometimes leave decimals in the answer depending on the calculator setup. Okay, so that would be how you would solve this particular question. You would also get, you could do the same equation and you would actually get the same answer if you use the 1.5 gram. So no matter how you do it, no matter which vial size you use, you'll get 4.7 milliliters. I specifically told you to use the 3 gram vial, but there might be a little bit more nuance on which vial you would use. But I couldn't discern which vial to use to tell you, like, oh, to focus on, oh, you would use the 4 or the 8 because, you know, if I assume that if you use the 4, you would actually need to mix 2 of those. I mean, if you use the 1.5 gram vial size, you'd actually have to mix 2 of them because it's greater than 4 milliliters. But like I said, on the test, it should tell you, and on the practice test, it does tell you to use the 3 gram vial. So. All right.
Sorry, what did you mean by if you use the 1.5, you have to mix the 2 of them?
Meaning that if the total volume is only 4 milliliters, but the answer is 4.7, then you would need 2 vials mixed in order to get to 4.7 milliliters. That's just more so for like the actual clinical application. Like if you think about if you were actually administering this.
So does it mean you would multiply the 1.5 by 2 before using it in the calculation?
Well, what that means is you, because I tell you to use the 3 gram vial, just focus on that. But if you had used the 1.5 gram vial, you would have just done the 1750 divided by 1500 milligrams times 4, and you would have gotten the same answer, 4.7 milliliters.
Okay, thank you.
You're welcome. All I was adding in is like the actual clinical stuff. So like, imagine you're supposed to give somebody, you know, 100 milliliters of something, but it only comes available in 50 milliliter increments. That means you're gonna have to give them 3 bottles of that particular thing. Or does it make more sense to just mix up 1 bottle of 200 milliliters and throw away the rest? It just depends on what it is and what's available and all that kind of stuff. So, all right. So so let's look at number 18. And number 18 now is another antibiotic. It's Pfizer pen. It says that there's 350,000 units. That's the order. Sorry, put that in there. Okay, 350,000 units. IM Q6H. And then we're going to choose the strongest concentration from the list below. Now, what have I just taught you about milliliters diluent added? What are you going to do with that column?
Cross it out.
Yeah, cross it out, ignore it, because it doesn't tell me the concentration. It just tells me, or tells the pharmacist, how much water to add. Okay, that's all that's there. And the reason, my guess, the reason why the nursing department has these types of questions on here is to make sure you can kind of filter out what you don't need and filter in what you do need when you're looking at a label, when you're looking at this. And you will see questions like this probably on the ATI, and then probably on the on your NCLEX when you take that at the end of everything, once you're taking your boards. So looking at the units per milliliter solution, and that's the other thing. That's what a concentration is. It's something per something. So usually, like, I could say the concentration of a medication that comes in a capsule would be like 250 milligrams per capsule. So you could say that that's essentially its concentration. What we usually mention, and we'll say concentration, suspension, reconstitution. When I say those, we're usually talking about something that has some sort of it's a liquid. So this Pfizer pen is coming in a liquid, and it's in units per milliliter. Now there's 3 listed there: 250,000 units per milliliter, 500,000 units per milliliter, and then 1 million units per milliliter. Which one of those would you consider the strongest concentration?
1 million.
Good. Yep. So 1 million units per milliliter is the strongest concentration. And so if I want to do an equation for that, I'm going to take this, my order was the 350,000 units, and I'm going to use the what's available, the 1 million units, and then I'm just going to multiply by 1 milliliter, because that's what 1 million units per milliliter is. And what I'm showing you here is what the formula that's called order over half. If you're going to do this dimensional analysis, which some of you have already told me you hate, this is how you would set that up. Okay. All right. And then when I do this, no matter how I do it, I'm going to get to the same answer. I'm going to get to 0.35 milliliters. Do I round that to 0.4?
No.
No. Remember, in the rounding rules, which we discussed last time, you want to have at least 2 significant numbers in your answer when possible. So like if it's a whole number, it would just be like 2 milliliters. If this was just 0.3, you would leave it at 0.3. But because we have a number less than 1, we would round to the nearest 100th place. So the only time we would round this up is if it were like 0.375, we would round that number up to 0.38. But we would just want these 2 significant figures in our final answer. And then you will find on some of your syringes that they will even go down into the 100th place, sometimes even into the 1000th place. It just depends on the syringe. When you get into 3rd semester, when you do pediatric dosages, you'll kind of see some of the more the nuances associated with this. All right, so those were the 2 main questions that were asked, and those are the ones that are good to know, is the reconstitution problems. And I wanted to tackle those first and foremost before I go back and kind of revisit some of the earlier things that we didn't cover last time. And again, if you're just coming on, I want you to know I do record these. I do give them to Professor Walters to post on Blackboard for you guys via the Zoom link, and they're also on my YouTube page. I posted my email earlier. If you email me, I will forward you a link, and the link will give you the practice test. And also, there's a URL there for you to click on to go to my YouTube page. But if you just search for Dr. Rad, the Rad Tutor, you'll see a picture of me, which is the same picture that you're seeing in my Zoom profile. And you'll see that I have a whole bunch of videos posted there specifically for you guys, meaning CCAC Allegheny nursing students, okay? So take advantage of that when you would like to. All right. So one of the things I mentioned last time is that most of the questions that are missed on these, and at least on this test, and even on second, third, and fourth semester tests, is forgetting to mark when it tells you to mark something. So marking a cup, marking what's called a tube X, so marking the syringe. Also not reading the directions when it tells you per day versus per dose. So make sure you read when it tells you to do that, and it'll say that very explicitly in the directions. All right, let me give an example here that I think will be helpful. Actually, I'm just going to go ahead right to one of the questions that's a little bit more challenging, and you may not have seen this yet, and that's the question pertaining to the syringe. And what I mean by that is it's a question about insulin, and it tells you to, it says, and this, for those of you who have the practice test, it's question 20. Question 20 says, your patient is to receive 36 units of regular insulin and 28 units of U100 NPH insulin. Then it has, the follow-up questions are, which solution and amount will be drawn up first? And then to select syringe A or B, mark the syringe with an arrow to indicate the correct total medication level. So I always tell students this, and this will be helpful for you. It's always going to be syringe B because I don't have another graphic. It's just A and B are the choices there that I was able to extrapolate from a previous exam. So it's always going to be syringe B, and you know it's syringe B because it has units is how it's being administered, and so that's why you choose the units syringe. So what I'm going to do is I'm going to draw up a syringe. I'm going to draw up a syringe. Just clear that up a little bit. We have a plunger side and we have the needle side. Now, the first question is, which solution do we draw up first? Now, I know that for many of you, you have not even started looking at insulin yet, but you always pull or you always draw regular first. So it's important to make a note, regular first. And then for this particular example, it was 36 units of regular first. Then it says we need to mark the syringe. We need to mark the syringe to indicate the total correct level. And they want you to mark the syringe in a couple of different ways. So I'll show you how that's done. So first of all, it says we have 36 of the regular and 28 of the NPH. And so that is actually going to be a total of 64 units. Okay, so 64 units total. So the first mark you're going to make is at the 64. Now, if you look at the syringe, you see how it'll say 10, 20, 30, 40, 50, 60, and then you look in between. Each of those marks in between are units of 2. So it goes 60, 62, 64, 66, 68, and then 70. So you need to make sure you're paying attention that each of those individual marks. So let me just kind of draw that out a little bit so you can see. So let's say this is 60 here. Then it would be 62, 64, 66, 68, and then this would be 70. And so you would make a mark specifically, I'm going to use a red indicator, at 64. Okay, and that would be your total at 64 units. So they want you to be able to pick that out, make sure you can tag it appropriately, and that's how that would look. Now, the other thing is, it tells you, sometimes it'll ask you to also mark where regular insulin would be. So regular insulin would actually be between the plunger side, closer to the 64 units, and up into the 28 units. And that would actually be where the other indicator would be, is, and I'll explain this in just a second. So let's just say at 28 units, your solution for the regular insulin is actually going to be in between 28 and 64, because remember, regular insulin is 36 units. So here's how this is done. Let's just pretend that regular insulin is, let's just say it's yellow. So hypothetically, regular insulin is going to exist in this dimension here. And then let's just say that the NPH is green, and it's going to exist up through here. So 0 to 28 is where you would find the NPH. So I'm just going to write that here, NPH. And then the regular is the yellow. Now, in reality, it all just mixes together. But I just wanted to show you where these are. And because sometimes they'll ask you to make 2 marks, 1 mark indicating the total and 1 mark indicating where the regular units would exist. And so you would need to know that your 2 marks would be at 64 and 28. And then I would add in the denotion that regular is between 28 and 64, which is the equivalent of 36 units. If that's confusing, I understand. It's confusing to me to try to explain it because I don't see how this is like math related. It's more about like technique, and you'll actually do this semester if you haven't done so already. And then, like I said, I have a link that explains this. I also have a graphic that I pulled from the textbook that explains this. And all that's in the link that I shared with you, or will share with you. If you don't have it already, just email me and I will get it to you. Anyways, did anyone look at that? Did anyone have a trouble with the syringe question?
Yeah, I don't get that.
Okay. So the biggest thing is just to practice it and know where to put your marks. And so if you can do what I did, then you can do it. It's just a matter of adding them together, making sure the regular is close to the total mark, and you won't have a problem with it. Now, on this particular question, it just says to mark the syringe with an arrow to indicate the correct total medication level. So it doesn't tell you to make 2 marks. So I don't know if they want you to mark regular and total or not, and that would be something to clarify with your lab instructor.
Well, if the regular is 36 units, what I don't get why it goes all the way up to the 60.
So when I initially draw up regular, you're exactly right. You draw it up to 36. Then I'm going to pull NPH, and the NPH is going to push the regular still, and it's going to keep it back towards, I call the back of this thing, I call this the plunger side. I'm sure it has a specific word, I don't know. I call that the plunger end. And so when you're pulling the NPH in, it's going to push the regular closer to the plunger side. So that's why I drew it in 2 different colors. So the yellow would indicate the regular insulin. So that was pulled up first. So let me do something here. Let's say I only drew up regular, okay? If I only drew up regular to the 36 mark, it would be in this yellow section. But I don't have just regular. Now I'm going to add NPH. And when I add NPH, that's where I'm going to get, so I'm not going to necessarily make marks on this one. I guess I will. The yellow stays there. What happens is the green fills in here, and then the yellow fills in the rest. And that's what they're trying to get you to look at. So where the yellow is the regular and the green is the NPH.
So you're saying like when they pull it up, it's going to be towards the 64, but it's still 36. So basically, if you subtract that, then the regular would be from the 64 to the 28.
Correct. Yeah. So 64 minus 28 is just 36. So
Okay.
this is still 36 units in here, and this is still 28 units in here. So that doesn't change. It's just the positioning. In
Okay.
reality, what really happens when you draw these up, I'm going to draw another syringe because I'm just having fun with this now. When you draw this up, what happens is, so you have your regular, right? That gets up to 36. And when you pull the NPH, now it just does this. Everything just gets mixed together. So you have yellow and green all mixed in together, totaling 64. But I think they try and get you to kind of navigate and rationalize that the regular would be drawn at first. And so what I always recommend is that you always indicate what you're drawing up first. 36 units, regular first, then make your total, then you make your mark at 64, your total mark at 64 units. And then, like I said, they may ask you to mark where the regular is, and just know that it's between the NPH and the total mark. With a little bit of practice, you'll get that. It's just one of those frustrating questions, but a lot of times, again, I've actually, even as confusing and frustrating as that question is, most people don't miss that question because you focus on it so much. So, all right. A couple of the other questions that I thought were worth going over just for practice. These are things that you're going to get into and you're like, oh, I got this. This is actually not too bad. So let's look at, or I know some of you don't have your questions in front of you, but I'm going to go to question 6. Question 6 says you are to administer 250 milligrams of Diluent. So what I'm going to do is I'm just going to write down the specifics. So question 6 says the order, I'm just going to denote that as an O, is 250 milligrams. And then it says Diluent by mouth. And then it asks how many teaspoons. So I'm just going to say question mark teaspoons. How many teaspoons will you give if it's labeled as shown below? And the label shows, so I'm just going to write the label, we'll just indicate it as L, tells me I have Diluent 125 milligrams per 5 ml. Now, what is the relationship between teaspoons and milliliters? Does anyone remember?
Milliliters for every 1 teaspoon.
How many milliliters?
5.
Oh, okay. I didn't hear the number there. So good. So yeah, 1 teaspoon is 5 milliliters. Okay. Okay. Now, because we know that, we also know that this number right here, the 125 milligrams, is the same thing as 1 teaspoon, right? So sometimes you can find these shortcuts, and then you can save yourself some time when you're doing the math. But I'll show you the 2 ways to solve this equation, and I'll also show you how this equation gets missed more often than not. So the order was the 250 milligrams. And then I'm going to show you the order over half method. What we have is 125 milligrams. And then the simple way would be, my quantity would be 1 teaspoon. And then I do that, I get 2 teaspoons, I'm done. The other way you would do this is, let's say, again, order over half, 250 milligrams, 125 milligrams, times the 5 milliliters. Now, when you do this, you'll actually get 10 milliliters. This is actually where people get this wrong, is because they didn't read the directions. They were trying to go quickly. Or you might remember this question and it said how many teaspoons, but then on the test, it actually tells you how many milliliters. So just make sure you read what the equation tells you to do, or the test tells you to do. So if this is supposed to go into teaspoons, you just need to know to convert milliliters to teaspoons. And so again, you need to know how to do that, okay? And that's where the 5 ml and the 1 teaspoon come in handy, and you get to the same answer. Notice that in this situation that I'm circling in red, I actually, that was just a one-step equation, and I kept it simple. And all I did was convert 5 ml to 1 teaspoon. That's perfectly fine. They're equivalents. You can do that. All right, so that's number 6. Remember when it tells you BID or when it tells you BID or it tells you per day or per dose, you really need to pay attention to that. So if it tells you per day, make sure you account for whether it says BID or TID. So let's just go over some of those real quick. So when you see QD, sorry if I can write the letter, that just means one time, okay, once a day. BID means 2 times per day. TID, 3 times. QID, 4 times, okay? Now, a couple ways that this could also be written out and mean the same thing. Q24H. This could be Q12H. This could be Q8H. And then this could be Q6H, okay? You could also have Q4H for 6 times a day. I mean, so you have a variety of ways in which this could be represented, and sometimes it's big Q, sometimes it's little q. It just depends. Okay, I'm just letting you know that when you see these things, that's some of that stuff, what that looks like. You do want to pay attention at looking at labels. There should be some practice on labels in your packet. As I recall, there is a packet that you guys should have received at the beginning of the semester that goes over the drug calc stuff. And there's some practice things. I said I made this packet like a long time ago, so I always forget what you guys have in front of you because I haven't seen it in a long time, but you should have some review material. And then the practice test was just updated as of 2017. So I'm going to jump over to number 11 because I think number 11 is good to look at. So number 11 says that the physician orders Valium at 7.5 milligrams. For Mr. Smith's anxiety, you have Valium tablets of 5 milligrams available. Okay. And we want to know how many tablets to administer. So this is 5 milligrams per tablet, and I'm just going to abbreviate that tab. So my question is, how many tablets do we give Mr. Smith for his anxiety? So you start off with 7.5. Now, if you're like me, and I imagine you are, you don't like to do math with fractions. So another way to write 7.5 would be to write 7.5. Now you may also feel equally averse to decimals, but at least you can plug that into your calculator easily. So if I'm doing order over half, 7.5 milligrams over 5 milligrams times my 1 tablet, and then what I get is 1.5 tablets. Now, your instructors don't want you to write 1.5 tablets. When it's a tablet, if this were milliliters, that'd be fine. But what they want you to actually write is 1.5 tablets. And like I said, you'd want to clarify that with your instructor just to make sure that that you are writing it down the way that they want you to write it down. But that's most likely how you're going to be asked to write it down, as 1 and then 1/2.
Can you do like because how I've been doing mine is put 1.5 or 1.5. Will they mark that wrong?
They might mark it wrong. That's why I was saying to clarify it with your lab instructor what they want you to write. So from what I understand, like if it's a tablet, they want you to write 1.5, like this. That's what they want you to write as your answer. If it's in milliliters, it probably doesn't matter.
So they would mark it wrong if you put both?
I don't know that. That's why I'm telling you to clarify with your instructor.
What
I'm not the
instructor?
one.
Because every instructor I ask, where are we doing the calc test? They don't know. So which instructor is it?
I don't know. That's a good question. If you ask Professor Walters, and she should be able to tell you. It's usually week 5. I'm sorry. It's usually week 5, week 6 is when you'll have your dosage calc test.
I don't think I have Professor Walters. I don't think.
What's that?
I don't have Professor Walters.
Oh, okay. Well, whomever is I guess the head instructor for whoever teaches your lecture, I would just start with them. Who do you have?
Lecture for 110, you mean?
Yeah, who do you have for 110?
I have Harchel Road or something like that.
Oh, okay. I don't know who that is. But I would just start with them and ask what they need from you. So how many labs do you guys have?
I have 110 and 120.
Oh, okay. So yeah, I don't know which one it is. I mean, the name of this course or the name of the test is 110. So I imagine it's the 110 test. So it's probably whomever's teaching 110. Lab, yeah.
Okay.
Yeah. So I do realize you don't all have Professor Walters, or at least now I'm aware of that because I know there's day and there's evening. So, and I'd like to tell you I know everybody who's teaching everything, but I do not. So. All right, let me go through another good one here. Let's see. There's a question 21 about Tagamet. And this is actually a good one to go through because it includes some other things that are important to go. So I said 21. And this also helps us to do some additional practice for just doing your basic conversions. So the order is cimetidine, which is the generic name for Tagamet, 0.8 grams, okay? And then it says POQID, meaning that you would administer 4 times a day. And it wants to know how many tablets to give per dose. And then, so your order is the 0.8, and then your available, or your label, I know I interchange A and L, so whatever I call it at this moment, is 400 milligrams. Now, one of the things that's important is you cannot do easily. I mean, you probably could do this in your head just fine, and you'd be like, oh, it's 2 tablets, I'm good. But if the numbers are ever more difficult, it's important to know how to do this. You can't have grams and milligrams separated. You need to convert either milligrams to grams or grams to milligrams so that they're both equal. So what I recommend is going from 0.8 grams to milligrams. So you can do that just by moving your decimal point over 3 to the right, and you would get 800 milligrams. Okay. If you need practice on this, remember your 0.8 grams. Put my decimal in here. 1 gram is equivalent to 1,000 milligrams. And then that's how I got my 800 milligrams. If you need practice, that's somewhat of why these questions are asked this way. Or you can just move your decimal 3 to the right. That's what I do. And then when I'm solving this, desired over have my 800 milligrams over my 400 milligrams times the 1 tablet gives you 2 tablets. So you would give this person 2 tablets per dose 4 times a day. So remember that when you're looking through these, that you convert grams to milligrams or milligrams to grams or micrograms to milligrams or milligrams to micrograms, so you don't so that you're in the same unit. You want to be in the same unit when you're doing that. And then, like, for some reason, if this said, like, 0.8 drams and how many milligrams per milliliter, you wouldn't have to worry about that. But I'm just saying, if you have something like that, you basically are talking 2 different languages and you're not going to be able to easily do math with looking at two different languages unless you are, we'll just say, fluent in both those languages and you know what the conversions are. So if you're sitting there going like, what's a dram? Well, a dram is typically, it's considered an apothecary unit. And if you have perfume at home, if you look at it, it'll tell you that it's usually measured in drams, which is some equivalent of ounces. They used to use that in pharmacy and pharmaceuticals, but they don't, at least not readily anymore. So you shouldn't see that on any tests, including ATI or NCLEX. But saying that, I could be wrong, and these things happen. Oh, let's see here. All right. And I just want to see if there's anything else. That's good to look at. Okay. So I don't have any other specific things to look at. I know that I've been asked to look at the ATI, but I haven't had a chance to look at ATI yet to see what type of drug calc questions you have on there, but I will take a look at that and be able to help answer any questions. But do you have any other questions revolving around your drug calc test?
Are you going to do this next week too?
Yes, I'll be here next week as well. Yeah, so I will be here next week, 3:30. So Tuesday, September 8th at 3:30. All right. Well, if there's no other questions, then
Are you going to post this? Are you going to post this Zoom meeting on our website on the CCAC?
I will be giving this to Professor Walters, and then she'll put it on her Blackboard, and then I will put it on YouTube, and then I'll just, so you know how to get to my YouTube, I'll put it right here.
Okay.
It's going to be, if you go to YouTube, and search for, it's going to say Dr. Rad, and then you'll see, and then it says sorry, I'm on a tablet, and so it's hard to do all this stuff. So, but if you do a search for Dr. Rad, the Rad Tutor on YouTube, I will post these on there as well.
All right. Thank you.
You're welcome. You're welcome, Jess. Thanks for the feedback. All right. If there's no other questions, then I'm going to go ahead and end this.
Thank you very much.
Actually, this is Jess. Real quick, I was for some reason not able to retrieve the documents from the first YouTube, and I did go to Blackboard to the NUR 110 120 orientation where we have general information for all classes, and under the drug calculation workshop, it just gives the link and the code to your last video, but it does not provide the link to any of the documents.
Okay. So here, I'm putting in my email address. If you email me, I will forward you that link.
Great, thank you.
You're welcome. And then if you if you have a way to disseminate that link to anyone else who needs it, by all means, go ahead. It's not a secret link. It's for all the 110, 120 students.
Perfect. Thank you so much.
Yeah, you're welcome. Oh, you're welcome, Kaylee.
Thank you.
You're welcome.
Bye.
All right. See you, Dora.
Hey. All right.
All right. Take care.
You too. Thanks. Bye-bye.
You're welcome. Bye.